Welcome back. My name is Kevin Togoff on Catalyst University. In this video, we're going to discuss the mechanics behind a linkage problem in genetics. These can be very challenging problems if you don't know what you're doing, and they're easy to get lost in. But we're going to go over how to do these in the most effective way possible, and then after this we'll do some practice problems in addition to this. Here you're given a table. What you'll typically be given are just phenotypes and the number of occurrences of each. You will definitely not be given the classes here, which I already have filled out, and you may or may not be given the total. I've chosen numbers to where they purposely add up to a simple number to deal with 1,000. So the order here goes A, B, C, and the plus signs are the capital letters. You might see, in this case, capital A, capital B, capital C, or just plus, plus, plus. It's understood that they're capital letters. Lowercase letters are just given as lowercase letters. All right, the first step is identify the parentals. This is probably one of the easiest steps. These may not be given in order. They're certainly not here, although the parentals are the ones with the highest numbers of occurrences. So obviously 330 and 320 are far higher than any of these other numbers, relatively speaking, so these two cases are the parentals. They will not always be the all plus signs or the all lower cases, just so you know. In fact, the next problem we'll do in the next video, they will not be. They're the ones with the highest number. Okay? Now, in step 2, I don't have this written explicitly, but you should also identify the double crossovers. Those are the ones, in contrast, that have the lowest numbers. So let's read the other ones. 64, 10, 66, 100, 15, and 95. Well, 10 and 15 are by a pretty large margin the lowest numbers, so the double crossovers 1 and 2 respectively would be this 10 for A++ and 15 for plus BC. So now I have both the parentals and the double crossovers. What I need to do is figure out the gene that's in the middle. When I compare the parentals to each of these double crossovers, in one case, one letter changes and the other two stay the same, whereas in the other comparison, that same letter stays the same while the other two change. Now I'll go ahead and tell you it's A, but let's look at Y. So between the parentals and this double crossover, you can see A changes. It goes from plus to A, whereas the other two stay the same. They're both plus signs in both cases. Now in this one, the A we would expect to actually be the same because it changed here. So A clearly stays the same and the other two in fact change. So the gene that's in the middle is A. Let's verify it with this to make sure it works, just so we didn't make a dumb mistake. So A stays the same here, the other two change. So A should change here, A changes, and B and C stay the same. So the gene that's in the middle is A. Now I can either write the gene order BAC or CAB. It actually doesn't matter, and given the information we have, we cannot actually tell what the order is, whether it's BAC or CAB. The only thing that needs to be accurate is the gene in the middle, because all else depends on getting this part right. Okay? Luckily you can check this with both parentals. Okay? A is the gene in the middle. Now what we're going to do is we're going to ask ourselves which single crossovers pair up. To do this, we're going to make a diagram like this. Okay? What we're going to do is we're going to write both parentals in the arrangement here. And what that means is basically we're going to put them in the order that we just found. Remember we found that this was the gene order, BAC? So we want to put them in this order. So write the parentals one horizontally this way. So we have ABC as the phenotype for this parental, but we're going to write it in this order, so BAC. Now the other one's all plus signs, so it really doesn't matter, but this is technically capital B, capital A, capital C. And what we're going to do is we're going to connect these letters, cross them over like this, okay? So get some practice doing that. This first crossover in both cases is going to be the first crossover. That's why I've colored them both green. And this one over here from plus to C and A to plus, this is the second crossover, which I've colored in magenta. You're going to read this left to right. Okay? Now just follow where my mouse is going, and I'm going to show you how it works. Let's look at the first single crossover. So I'm going to start with the first letter in each case. B, I'm going to do the first single crossover. B, plus plus. Okay, I'm only going to cross over once. I'm not going to cross over twice, just once at the green. B plus plus, because I'm reading left to right. So B plus plus. Now let's start on the bottom and do crossover up. Same crossover, the green one, plus AC. You'll notice over here, I have all the single crossovers. Basically, once you identify the parentals and the double crossovers, everything else is just a single crossover. But you can see plus B plus, I've written it in the order BAC out here to the side of each of these. Okay, so they're in order. So remember, I went B plus plus and plus AC. I only crossed over at the first one, the green crossover. So B plus 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 AC, I have those. B plus 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 AC. So these two must actually go together. Okay, those two single crossovers, which happen to be single crossovers 1 and 2. Now, let's cross over at the second one, the magenta one. BA plus, start at the bottom, plus plus C. So here I have BA plus and plus plus C. So these two go together. And again, these happen to be single crossovers 3 and 4. So now I've identified which ones pair up. I'm going to apply this formula. Let's do it for these first two, single crossovers 1 and 2 first. So I'm going to apply the formula. The first in the pair is 64. Okay. The second one is 66, so 64 plus 66, and then I'm going to add all the double crossovers, 10 and 15, which is 25, and then I'm going to divide by 1,000. When I just do that, I'm going to get this number, 0.155. That's technically the gene distance. However, it's in units of what are called Morgans. Typically, when we report this, we don't want to use decimals, so we convert it to centimorgans. So we're going to multiply by 100, and we get 15.5 centimorgans. Now, this is the distance between genes B and A. Now, million-dollar question. How did I know this is the gene distance between B and A and not between C and A? Well, think about where we crossed over. This was the green crossover. It was a crossover between B and A. So it's the gene distance between B and A. So the gene distance or map distance between B and A is, at least in the units that we typically reported, in 15.5 centimorgans. Now, this would be how you report it most likely on an exam or some assignment. But this number, this 0.155, prior to multiplying by 100, keep this number in mind because we're actually going to use this in a future calculation. Okay? Now, map distance between C and A. So I'm just going to use the other ones because I have to use those in a calculation. Plus plus C, that is that's single crossover 3, 100. The other one, BA plus, so BA plus is 95, single crossover 4. So I'm going to add 100 plus 95. Again, add all the double crossovers, which is still 25, that hasn't changed, and divide the whole thing by the total, which happens to be 1,000. Initially, that gives me 0.220. Again, just like in the case of this up here, keep this number in mind. We're going to use it to calculate what's called the coefficient of coincidence. But to get the correct units for reporting, I have to multiply it by 100, and I get 22 centimorgans. Okay? This is the map distance between C and A. Well, suppose I had done these first. Obviously, this is going to be the distance between C and A because I already determined this is the distance between B and A. But if I had done this first, how would I know it's between C and A and not B and A? Well, think of where I crossed over to get these. I crossed over at the magenta one, right? So I went plus plus C, and then went B, A, plus. So this is a crossover between A and C, regardless of which way you're going. A and C, A and C. So it's also the map distance between A and C or C and A, either way. So I know my gene order is BAC. I know the map distances. They are 15.5 centimorgans and 22.0 centimorgans respectively. I can also calculate the total distance between B and C. Sometimes they may ask you to do this. You simply just add the individual map distances together, and when I add 15.5 plus 22.0 centimorgans, I get 37.5 centimorgans. Okay? Step 4, this is just a calculation. I'm going to calculate the coefficient of coincidence. It's going to use this formula. I'm going to add up all the double crossovers, which is going to be 25 in this case. I'm going to divide first by the first distance. Now remember, I mentioned this. You're not actually going to use the centimorgan distance. You're going to use the distance that you did before you multiplied by 100, so 0.155. Okay? If you want to think about this, these are actually units of morgans. Okay? Not centimorgans. So you're actually going to use the distances in morgans. And then you're going to divide by the second distance, so it won't be divided by 22. It'll actually be divided by 0.22. And then you're going to divide again by the total, divide by 1,000. This is a calculation where you typically see a lot of math errors because of people entering things into calculators. When you enter these in, if you don't use appropriate parentheses, so if you do it all in one step, you can end up dividing by D1, but then multiplying by D2 and multiplying by the total. This will give you an enormous number that you don't want. So if you do this, if you're not really that good at entering things into calculators or you just want to be safe, take 25 or all the double crossovers, divide by D1, and then hit enter. Then divide by D2, hit enter, and then divide by the total, hit enter, which will give you your answer. Here's the coefficient of coincidence. We have 25, which is all the double crossovers. We'll divide by 0.155, or the map distance in just normal morgans, and then divide by 0.220, the second map distance between A and C, and then divide by the total, which in this case is 1,000, and I get a coefficient of coincidence of 0.733. And finally, on to the easiest step of all of this, we want to calculate the interference using this formula. The interference I is equal to 1 minus what we just found, the coefficient of coincidence. So the interference here is 1 minus what we just found, 0.733, and so my interference is 0.267. Okay? So hopefully this made a little bit of sense. These are the typical quantitative or computational steps that you can have for linkage problems. In the next video, we're actually going to do another practice problem.